Hello, everybody. Today is May 23rd. This is another working group batch meeting. As usual, remember that this meeting is being recorded and that you're expected to follow the Kubernetes and CNCF code of conduct. With that, we can move into the agenda. Let me share my screen real quick. This is probably too small. There we go. So we have Vanessa, who wants to demo ensemble operator, and then we'll talk about continue the discussion from a few weeks back about job set and Kubeflow. And I see that Amy just put a new topic as well. So Vanessa, do you want to share your screen?
Yes.
So let me give you co-host rights. Okay, you should be able to share your screen now. I'm gonna
Alrighty. And because it looks like we have two other items, I will try to be quick if I can. Sorry, I'm just clicking through sharing. So I'm not going to do the demo. One, it would take longer, and two, I don't have enough credits on Google Cloud. So I'm going to kind of talk about this because I still think we could talk about it and get pretty useful feedback. So to step back, the interesting thing about the Kubernetes space is there's kind of multiple levels that people work at when they talk about scheduling. So of course you have sort of the in-tree scheduler. You then have, out of tree plugins, but then you have something like Q that has a scheduler package that works as a controller, and you have other kind of things working on that level. And so then you have something like then you have workflows that are kind of orchestrating when things get submit based on something completing. But then you also have like success or failure policies that are on job set. So there's a lot of interesting work going on that are trying to basically control like how to run things and when. And so I had an idea that I want to talk to you about today called the ensemble operator. So some of you folks have probably heard of ensemble in the context of machine learning. And so in that context, that means that you basically train a bunch of classifiers and you ask them to vote. And the idea is that the accumulated knowledge will give you a better answer than if you just ask one little doopy classifier. An ensemble in HPC is similar conceptually, but what people usually will do is they'll be interested in kind of running a simulation across many kind of different parameter settings, and then kind of combining the results in an intelligent way. So if you're familiar with HPC, maybe you have an ensemble that has members of size 8. Each one has a slightly different number of parameters, and you have some metric of goodness that you want to stop at. And so when you think of that in the context of scheduling and the projects that I just named, you don't really, I guess you could have like a success or a failure policy, but what I wanted to experiment with is this idea that you could define very specific algorithms that would control behavior like scaling. So for example, let's say that something triggered an algorithm that said, actually, let's ask for 2 more nodes, let's increase the size, or I want to run these ensembles based on an increasing size, a decreasing size, the number in the queue. So let me first show you what this design looks like. This will kind of better explain what's going on, because the basic design is actually that you have an ensemble member of a mini cluster. So imagine that you deploy your own HPC cluster to the cloud. This is what a mini cluster is. It's a Flux framework entire cluster that you might deploy to some number of nodes. And because of the index job, because completions is equal to parallelism, that means that we can scale it up and down. So that's something that we can do programmatically, which is really nice. So in this mini cluster, you can think of this as an ensemble member. And the basic idea is that you are going to have your application here. So those familiar with HPC, like you might be running LAMPS or Lagos, or insert your favorite HPC proxy app or whatever. And then alongside it, so just if you're not familiar with Flux, Flux has its own scheduler, and it has its own scheduler, resource manager, job manager. This discussion is beyond this meeting here because those terms mean different things to different people. But basically, there's a queue in there, right? There's a queue that you can submit jobs to, and those jobs can be kind of selected based on some kind of logic. So the basic, I guess, and so alongside your application, oh, my treadmill is stopping. Can't have that. Just kidding. So alongside your application container, the basic idea is that you want something intelligent monitoring it, something that can say, okay, this is how many of my jobs have run. This is like the output. This is like so you could theoretically have, for example, if anyone's heard of River, it's a stream machine learning library. You could have a model that's building in here that learns, for example, how long different runs take or some configuration of parameters that's better, that's deciding what to run next. And the idea is that this model's being, or it doesn't have to be a model, but this algorithm is actually a service sidecar that goes back to the ensemble operator, which is what I'm going to talk about. And it's the ensemble operator that basically checks the status from the sidecar, which is looking at the queue, it's looking at the jobs, it's exposing whatever information is in the application container that you need, and then it's deciding what to do next. And so the flow of steps, since I just described that backwards, which probably doesn't make a lot of sense, is that you start by defining your ensemble. You say, okay, I want to make a mini cluster that's going to run across this range of jobs. I want it to have this particular algorithm. Here's the parameters for my algorithm. I'm going to apply that. And I want to scale up and down according to that algorithm. And then basically the operator is going to go back and forth and check for, there's basically a protocol that, well, the protocol is gRPC, but there's like a specific set of kind of functions, I guess I'll call them, that the gRPC client can check for that will say like, okay, this is the status. And then you decide to take actions based on that, where the most obvious actions are like scale up, scale down, do nothing, terminate, that kind of thing. And so what that looks like, so this was the demo I was going to run. I ran it on Google Cloud, and the basic steps are to create your cluster, wait about 360 seconds, then apply so this is the Flux operator. So because we're creating mini clusters, that's done with the Flux operator. Then we would also obviously install the ensemble operator, which is this first step here. Then we create the ensemble. And then it's really cool. And this is what I would have shown you in the demo. And I might actually make a video when I have more credits so I can post it and share. But you can basically watch the log of the operator and then that sidecar container, see them communicating, watch the cluster scale up and down to run your jobs. And it's really cool. I made this and I added, oh yeah, and to step back again, the demo also includes auto scaling. So the way that it'll work is that you'll ask the Flux operator to scale. The autoscaler will determine that there's too many pending pods or whatever. It'll actually increase the size of the cluster. So that'll work. So just very quickly, this is what the CRD looks like. Here's where you define the algorithm. This is just workload demand, which is a reactive algorithm in the sense that you submit all of your jobs to the queue first, and then you kind of react to them. So this order random means submit them at random order. And then here you define your jobs. So here I just have different sizes of lamps. But the idea, you could imagine an algorithm here that is training like a River model, the streaming machine learning thing, and then the models associated with the name of the jobs here. And then the mini cluster spec is just a Flux mini cluster. This is just, that's what the ensemble member is. So that's the high level idea. It's like, there is a scheduler in there. Flux has a scheduler and it has a queue, but it's sort of it's slightly more interactive than what you'd imagine you'd get with kind of something that just like chooses the resources and then sends it off. But it's, yeah. So I guess I'll pause there. I'm interested in kind of feedback, thoughts. I'm looking for like other ideas. I guess I haven't planned. I made this over a weekend as a fun project. I haven't done any like experiments with it yet. So I'm wondering what folks think and if there's any interest in something like this.
I have a question. Thank you for this demo, Vanessa. I think it looks great. So my question is like, I know that Flux has its own scaler, and as you said, we kind of like spun up the Flux cluster to start these jobs. So I'm just like wondering, with all these integrations on top of the Cube scaler, right? How you view the performance and what kind of like, challenges you're facing with combining these two, cluster techniques together, right?
What do you mean? You're not, like so I have another project called Kubescaler. You're talking, what are you talking about? What do you say? What do you mean when you say Kubescaler? You mean the cluster autoscaler?
Yeah, like basically, because I guess like Flux is responsible to scale resources, right? Because it has its own schedule which is running on the cluster. So I'm just like wondering in terms of
So
performance.
what
Yeah.
actually happens is that Flux basically, so the way that Flux works is that you have a configuration file that says like I have all of these nodes, and the trick that we do to support this elasticity is we tell it that it has many more nodes than it actually does. And because it's an HPC workload manager that expects sometimes actual nodes to go down, it says, oh, no problem. You know, nodes 0 through 5 are up and 5 through 10 are just down. And so then what happens is that when you actually change the size of the mini cluster and you move it up to 6, that issues a request to the scale endpoint of the mini cluster, which you can only do, as I said, because the parallelism is equal to the completions. Then that creates a new pod. There may not be resources on the actual Kubernetes cluster for the pod, but that's where the cluster autoscaler kicks in. So they're actually two separate mechanisms, but they work together. And as a result, you get your new pod, and it's pretty speedy on Google Cloud. Google Cloud, you get a new, you get your new node, and I've seen it up in like 30 to 45 seconds. So it's not super slow.
Does it mean that you need to associate every port with a node, or you're talking about like GCP nodes here when you're talking
Sorry, what was your question?
Like, I mean, do you need to like associate the Kubernetes pod with each node, which means like every pod sitting on the node to, you know, achieve this kind of, you know, scale, or kind of like async? Like, my question is like how you feed the Kubernetes pods with these nodes, right?
So have you ever used the cluster autoscaler?
Yep.
Yeah, you don't have to make any special association. You could. So I know there's a way that you can request a specific kind of node to be scaled up. And so your question is, if we did that, would there be a way for Flux to be for the mini cluster to be selective about the node that it gets? And I think that would fall under the jurisdiction of the scheduler, like the Kubernetes, whatever scheduler is running in Kubernetes. But usually for the experiments that I've done, especially with HPC applications that need all of the nodes to be the same, like even a different clock speed can kind of make an MPI application kind of wonky. What happens is you get a new node that's the same kind of, you know, VM as your other nodes, and then that's the one that gets, you know,
which means like
allocated.
You know, you kind of like basically with all this, you know, cluster techniques on top, usually you kind of, you know, because in Kubernetes, like if you just, you know, operate the primitives, right, you can, you know, use the node with the multiple ports, right? But since you have a cluster on top and you own autoscaler, basically you kind of like configure your like basically every node corresponds to the VM, which is like the Kubernetes. On the Kubernetes, it's like a single port, right? Which means like
that was a detail I didn't say. So there's a mapping of 1 pod per node.
Yeah, this is exactly my question was, right?
That's actually needs to be the case for Flux and for MPI. I have actually tried running it. So I've brought up a Flux mini cluster where I think, is it called guaranteed mode? Is that what it's called? It's not burstable, it's guaranteed. But what happens is when you kind of are controlling resources like that, which I'm sure is done with C groups, but I haven't actually looked at the code, you get errors, like killed, like really quickly. Like the tiniest little thing will kill your poor little pod. So in practice, I usually set the resource limit and request to be just under the total size of a node, so it's exactly mapped 1-to-1.
I have one quick question about the ensemble operator. To me, it sounds similar to HPA or KIDA. Because HPA has, well, it doesn't function with RPCs. I'm not sure actually. It might, but it definitely functions with metrics.
Yeah, I think the difference is that you get, so this is just with a Flux mini cluster. I guess there's a couple differences. One, because you're running Flux framework and you're using HWLock within that to basically see the fine-grained details of your cluster, you're able to do kind of fine-grained scheduling and topology mapping without needing to stress etcd or worry about Kubernetes, you know, API bottlenecks at all. So that's one difference. The other thing is that an ensemble member doesn't have to be a mini cluster. It could be something else. And I think it comes down to that you're able to be closer to the application that you're running and really use any kind of data from the application. I mean, I guess I guess you could take a similar approach and write some kind of thing that only produces metrics for HPA. But then the problem is that then you're still constrained with the actions that you're able to do based on that. Like you can't get creative and try things that HPA doesn't support unless you actually change HPA. I don't know if that makes sense.
Right. Yeah, absolutely. Which, yeah, I guess HPA in a way is extensible, so it can be extended in that way. But there is also the KIDA project, which it is my understanding that it has a lot more algorithms, but I'm not.
Yeah. So the goal of the ensemble operator would be to have a lot of really kind of interesting algorithms that may not translate into like one value for one metric that turns into like a very specific action.
Yeah, just that's what I would compare it to from the projects that I know of today. Maybe we're just like making sure you're not duplicating or reinventing the wheel, things like that. But otherwise, yeah, the idea of scaling based on internals of what is running, what is actually running is very useful.
Yeah. So I guess if anyone has like interesting use cases, I actually want to do something with River, with machine. Have others heard of River? It's a streaming ML library. It's supposed to be like scikit-learn, but for streaming ML. I thought it was, the typical use case they talk about is like for the stock market, where you have like a live data stream coming in and you want to build all the models that you would traditionally build with big chunky matrices, except you want to do it with streaming data. And so River basically kind of re-implements a lot of these algorithms to use that streaming model. And because of that, it's really perfect for this use case. At least I think so.
Okay. I think we need to move on to the next topics.
That sounds good. Thanks everyone for listening and for your feedback.
Thank you. So Andre, you would be next. Do you need to share your screen at all?
Yeah, maybe I won't take much time, like, because it's just initial. We can definitely. I don't think we have John here and Yuki on the call today because it's very early for them. Yuki, I think he based in Japan, and John in India. So I think maybe I can share what we have by by today, and then maybe we can have a follow-up discussion on next week or week after next week, what we can do for the short and for the medium and long term, right? Yeah, just like to give the context, right? We started discussion around after the KubeCon in Paris. So we want to consolidate the effort between the Kubeflow community and Bash Working Group community to reuse the functionality such as job set and jobs in the training operator. Because historically we've been orchestrating the Kubernetes workloads for ML training and for ML distributed training by ourselves in the controller, because Kubernetes Bash job by the time didn't support like success policies and other requirement policies that need for distributed training. So we just propose some ideas how we can structure this API. Let me just share my screen so we can take a look together. Just a second. So before I go through the doc, Aldo, do you want me go through the issue, or you want me discuss this issue first? What do you think? How do you want to structure this time?
I think it's up to you. I'm actually not following directly all the updates to the doc.
Okay.
So if you can give a summary of what's the latest on the doc, that would be the most useful.
Yeah, absolutely. So yeah, we're still trying to see how the API might look like to reuse the job set API within training operator. And like this is the previous doc that I think we discussed in the last Bash Working Group call where we on this one. Yeah, I don't think we have it here. Yes, maybe this one. So basically, like how we can consolidate the effort, what is the problems in job set today, why, what kind of features we need to implement. And the idea was to sometimes we have like very ML specific framework use case when probably it should be like out of scope of job set. And for that specific use case, we want to like reuse the training operator and provide additional functionalities for users who might have some specifics, like, for example, PyTorch Elastic or API jobs, or is just something which cannot be part of the job set. And what we're trying to do, like we try to summarize, like we try to see like what is the value of Qflow part and what is the value of job set. So our initial thought is, the MLEs and the people who know infrastructure, they kind of like a different set of people. We want to like provide a simple API for data scientists so they can quickly, iterate on their tasks, on their training. So they don't need to really learn a lot about Kubernetes complexities and all this, APIs from job set. So we propose several design. This is like still very early. Like we don't know what kind of structure will look like in the final way. So the one idea that we propose is having like the unified train job spec and where we have like different policies for frameworks where it will be required. We still don't know if it actually requires for every framework because as far as I know, like XGBoost, TensorFlow, JAX doesn't require a lot of APIs that we need to force to the user. Usually just some master worker specification or TF config that you need to specify in an environment variable. In order like PyTorch support is kind of elasticity, where you have to specify the backend of elasticity and other parameters like yeah, I think we have it somewhere somewhere here in the torch policy. Let me see. Yeah, so basically like an elastic policy, like what kind of backend you want to use, whether you want to use rendezvous or etcd or other parameters, or like in a standalone mode. Some of the parameters like very specific to PyTorch. So the problem with this approach is that I think Kevin made a comment that Daniel made a comment that probably it is not very Kubernetes native, because the problem with this approach, like user always will specify only single policy, but we kind of like don't have this distinguished. So we have to solve this problem on the validation side, which means like we should block the submission of two policies under same spec, which is not ideal. We need to still think about how to structure it correctly. Go ahead, Abdullah.
So another way to do this, I don't know if you looked at how we're doing plugin arguments in the scheduler.
Yeah. Is it in the queue or in the job?
No, this is in the scheduler. So you could define like an object, like there's an object, right?
Okay.
That you could parse, like you could parse like later in the validation, right? Like so.
Yeah. Go ahead.
Probably that is another approach to make it a bit cleaner here.
Yeah, is it similar to, let me show you something. So
where is that?
So it is like let me show you one second. So it's an unstructured. Yeah, so we kind of like have this API in one of our Qflow jobs, which call like, trials, and we're passing this as an unstructured object here, which means like, and then on the, on the validation side, we can check it, but I don't really like unstructured. And, sometimes unstructured, like we cannot properly like, configure open API schema for this. But like if you have any other ideas like with the object, maybe you can share some, because like Kubernetes doesn't support one-off, right? Like by default, you cannot specify like one-off in your, in your schema, which means like you have to like allow user to pass everything, and you need to parse it on the validation side, right? Any type of object.
I mean, and like in the, can we define a kind and then we force validation on that kind? Like an object kind.
Yeah. So can you give me an example?
Oh, I know where this pattern is really common. So I've seen this very commonly when you have like a mutating admission webhook, and you want to handle more than one thing, and you kind of shove a check for, okay, is this a pod? Okay, if it's a pod, then you want to add labels in this way. Is this a job? You want to add labels in this way. I can send you a link after for where I've seen that, but it just takes in a generic, Kubernetes object.
Yep. Yeah, so maybe we can take a look at like what you all shared as well. Yeah, so maybe we can propose something better here. But it's like separate. Like I think the most interesting thing that you might maybe spend time to discuss is runtimes. That's actually, I think it's kind of like continue your idea you propose with the job set template. So the idea is to how we can simplify life for data scientists. Because today on the training side, like usually the data scientists, they do a lot of iterative tasks. So they kind of like open their notebook, they kind of define their model, they want to tweak some parameters, they want to build the layers, and then they want to like, test it on the notebook. And then they want to, use distributed training to scale to multiple GPUs. Sometimes they can train the model for maybe a single epoch. Sometimes they want to train the model on like, on the large scale use cases for multiple times. So the question is here, can we structure an API in some sort of way to give them a quick ability to have a predefined runtime? Because like, for example, on the serving side, and I can give you an example for Kserve, they have a concept called the serving runtime, when basically we kind of like pre-deploy a number of runtimes, which actually has all the configuration for Triton or PyTorch or other frameworks. And then people, when they deploy inference service, they can reuse this runtime to serve the model. So they don't have to build this kind of, runtime. So on the training side, can we do something similar when, we can have some sort of PyTorch runtime, maybe TensorFlow runtime, and this runtime can be reused all the way from the notebooks experience to the large-scale distributed training experience. So this is more interesting, like, and this is still very early. Like we think how this, could be implemented, whether you're using the job set template or something else. But I think it sounds interesting that how we can achieve more kind of interactivity, right? Between the development phase and the like how these jobs have been spawned on the cluster, right?
You have more concrete examples. Sorry, I did not.
Yeah, let me show you. So on the case of like, because the problem is training is much more complex than serving. Because in serving, basically you just have an application and you just need to serve this application on the cluster, and you just need basically it's like a REST API application, right? And maybe you have some sort of the transformers, right? Another part, but on the training side, however, like you do a lot of iterative tasks. You kind of maybe train your model for one epoch, you see that your performance is bad, or maybe you achieve overfitting, you want to tweak some parameters, you want to run training again. So which means like there are a lot of iterative tasks before you kind of like can like productionize your models. And that is why like the experience might be different. So the idea is like on a Kserve side, there is a concept called serving runtime, where they just define the container and the image, like pre-created image, and like some other parameters like model formats. And these serving runtimes can be reused inside the inference service when you kind of like can just point to the serving runtime when you spawn the service, right? And the user doesn't need to even create this container, right? So you kind of like pre-create it for them with the appropriate, libraries, binaries, all the configuration, right? So can we do something similar, but on the training side, right? Because it sounds like, the experience might look very interesting from the Jupyter, because again, as I said, right, they spawn the notebook, they do some prototyping, and then they scale it to the, to a large scale distributed training experiment, right? Yeah, so we still think about how this could be reused, and again, maybe just initially reusing the job set template where we can have a pre-created job set for them, so they can directly reuse them, right, and just reference it. Like for example, we have like job set template for PyTorch, right, or job set template for TensorFlow, and they just point it to their their template, right, and we can pre-create these runtimes for them. I think the bigger question, how to bundle the user code to this runtime. Because runtime is just a container, right? With the installed libraries, but how you can, serialize the user code and maybe some part of the model in this runtime. So it is like an open question. Like we still need to think about this as well. But it's just like one of the idea that we maybe can think about, right? To simplify the experience especially for data scientists, right?
Interesting.
Yeah, so maybe when we have some ideas, we can discuss it again. But just to maybe want to hear your thoughts on this. Yeah, and I think like another approach that I think Yuki proposed was about controller name. So basically, this is a similar idea to Ingress class, where we can define the controller name, which you're going to reconcile the custom resource, right? And then we're gonna have like a different kind of a controller for every framework. But like we need to think about still in terms of maintenance, like what is the, will it actually give any value for the user? because by all of this, like I think the end user value, like what's kind of like thinking that's, a job set could be in the infrastructure level, but the experience level could be like, delegated to these Kubeflow jobs, which means like, some integration with like model registry, Spark, or any other parts of lifecycle can be part of a train job, and the infrastructure for, multiple jobs could be delegated to the job set, right? And of course, like API use cases, right? Like when we need to create additional resources like config maps, airbag, secrets, right? We just couldn't do this on the job set level. Yeah, so I think we have another topic. So do we have any maybe questions? It's still very early. Like we still need to find time to work on this. And there are several issues that we opened on the job set as well. So we'll try to find time to work on them.
Yeah, that would be my ask here
Yeah.
as well, to help us,
Yeah.
execute on those open issues.
Yeah.
I think we can provide review capacity definitely, and but I don't know if we have enough hours to execute.
Yeah, I understand. So let me speak with with Yuki and also with other folks from the Qflow side and also with my team to see like how we can contribute there. And like what is the timeline for this new API? Because the bigger question we need to answer, what about scalability? Because we got like a question, if you're going to deploy these two controllers, it would be as scalable as we just have a single controller, right? Especially in a lot of use cases.
I don't think that's an issue. The scalability is more about managing the workload itself, which at least for the most part is going to be delegated to the job API, and the job API is we've proved that it's a scalable controller. Ideally, those controllers are going to manage they're not going to manage a lot, right?
Yeah, ideally, like if we want to reduce the load to the API server, we don't want to watch for the pods, for example, because yeah.
So that's actually the main point with JobSet. We don't want it to do any of these things. Ideally, it's just job is doing the heavy lifting.
Yep.
And we're just sprinkling some extra features on top.
Yeah. I think that's right. But I think we definitely should reconsider all this reliability and scalability issues if we're gonna introduce another layer on top, right? And what is the value, right? What is the main differences, right, between these two entities? So I guess the next thing, let me follow up with other folks, and maybe we can have a chat maybe next week if you're available. And maybe I can produce some more ideas in terms of this training runtimes, because I think it sounds very interesting. And we hear a lot that data scientists, they don't really know how to quickly iterate from development to production, especially on the notebooks use cases. Yes, Ray sometimes addresses problems because you have a cluster, you can do prototyping, then you kind of serialize your function across the workers. But sometimes if you don't want to have a stateful cluster which is always running, how you can make this more configurable, right? With the Kubernetes native primitives, right? Without spin up another stateful service, which right now Ray, for example, is doing, right? It's spawn a cluster and do everything inside this cluster. So how to achieve again the batch part and the interactivity in the same kind of life cycle. Go ahead, Vanessa.
I have a very naive question that's it's related to both these things, but it's slightly unrelated. So if you want to finish your point first, and then I'll ask.
No, I think I'm almost finished. So I know I'm good.
So my question is, when you're using JobSet and maybe you're doing it at scale, or imagine a future where JobSet is mapped into Kubeflow pipelines and you can, interact with it from a notebook, how are you dealing with storage, especially if it's an ephemeral thing? Because a lot of these models, you need, almost I guess there's different access types, but I would assume some of them have a need for shared access to something that looks like a file system. And if a pod goes away, right, you need to reload its state. Where is that state being stored?
Yeah, we have an issue for stateful jobs for this, because the most naive approach to use read write many PVC, but sometimes it just doesn't work. Like I know that K-Serve team, they have some sort of the model car concept when they basically use OCI to have a sidecar, which is load the model on every pod, and this pod has an access to the model. We haven't tried to use this on the training side, but it also, I believe, has some sort of potential. So basically, like, storing the model on OCI, but again, like the Docker also has some limitations in terms of the size. But like the stateful index jobs will be required to have an ability for us to generate PVC across multiple workers, right, and machines to read the data. But usually, yes, you might have like master node where you download your model plus dataset and you distribute it across all the workers, right? It's also like interesting question about how you can even distribute it in memory. Like imagine you have a Spark workload and you have maybe a training workload. How you can directly get the data from the Spark workers without hitting the S3 or GCS all the time. So is the thing that we actually thinking about how to even streamline this experience from Spark to training, and have a direct access, maybe using Apache Aeroflight. So Apache, like Aero is actually, a format to store data in memory, and have a project called Apache Aeroflight, which is kind of microservice to have an ability to you to fetch the data between the workloads, and all the data stores in memory. So there are some like different techniques that we can do to streamline this, but it's always like a problem how to share this, especially for the large models, right?
Is the memory, is that RDMA?
Sorry?
Is when you're sharing via memories, are you using RDMA?
Yeah, so can you explain a bit?
Remote direct memory access. So like in HPC, like that's something that we commonly do for things like MPI. But my impression of at least on Google Cloud networks is that the optimization is for high bandwidth, and that's a little bit different. So I'm wondering if you do use that approach, is the network going to be supportive of that?
Yeah, I think it's a good question. So it really depends on device placement, right? And I mean, if you so as far as I know, like I mean, it depends on what kind of cluster you have, right? So like if, for example, if you have a HPC based cluster, you have to use MPI with specific when your device is connected up with a specific connection, as you said, right? Sometimes you might use like a different techniques, but like I haven't I didn't do performance check by myself, but as far as I know, like MPI, that is why people use MPI for HPC clusters, right? Because it's just faster than using just the PyTorch on the regular Kubernetes clusters, right? But it like it really depends on the use case and what you have, right? What kind of clusters you have in availability.
Okay, cool. Yeah, no, it sounds like that is still a large unsolved problem. I think it's a really hard problem, and I don't mean to ask a really hard question, but storage in Kubernetes is kind of hard, and I expect it sounds like the solutions are like PVC, and then OCI. Probably when you say OCI, you're probably talking about ORAS, OCI registry as storage. So basically pulling the model down from an OCI registry.
Yeah, so I'm talking about the concept called model car. It's like some new name of like in the K-Serve community, it was proposed that hey, why just not again fetching the model on the sidecar using Docker, and then getting this model on the other container by sharing the processes, right?
Yeah, I've done that trick. Okay, awesome. Yeah.
Yeah, but it has some limitations. So it has some limitations in terms of the size, right? So yeah, that is why different set of folks using different techniques for different use cases. Yeah, so I guess the next step would be to sync with me with other folks to see what we can work on, right? And in terms of the timeline, so since like Abdullah, Daniel, I'll do here, like, when you want to migrate the job set to V1?
I mean, we were planning to do it this cycle, but now we're waiting for these features to
I guess so. My question is to you, what is your long-term goal for job set? Like, do you want to stabilize the API and find adoption on how you
like I mean, for at least on Google, like on GKE, it has significant adoption for TPU training. Definitely we want to maintain it long term and graduate to V1. Like as I mentioned, we were planning to do it this cycle, but we're holding off to see if I don't anticipate that we will need to make changes that would require, like that would cause a backward incompatible change that would require us to go V1 beta 2 or whatever.
Yep.
So I'm like 90% confident that we can go V1 now, and then whatever like features you want to add, it would just be compatible. It would work. It would like cause no like backward incompatibility problems. But yeah, it's basically the court is in your field. Like if you at least, rather than like not necessarily execute, but like put the proposals forward, how you want to implement these features.
Yep.
And based on that, we can decide, well, it's safe to graduate to V1 while we're executing on those pending issues.
So I guess like TPU and large scale JAX is like your current use cases, right? Did you try to experiment anything else, like, running
we
jobs?
have some GPU workloads as well, but 90% is like massive multi-slice TPU training.
Mm-hmm.
Is that why I can't get any GPUs on Google Cloud? Is that because you guys are using all of them? Okay, noted.
Yeah, I guess that makes sense. But any plans for you to do benchmarks like for for PyTorch, or you like focusing on TPUs right now?
What do you mean, like
basically like any
yes?
like no, we using PyTorch, right? Just to see like how job set like run with Torch run. I guess I mean it won't
But it
be.
doesn't matter. Like it's not a factor here, right?
Yeah. Because the slicing of TPU, I guess like you're solving this on the device level, right? Not on the job set level. Job set is just scalar, right?
Right. Oh, I see what you're saying. Like basically taking care of topology aware placement.
Yeah. Yeah.
Yeah, I mean, on our end, like the TPUs are split into slices, and each slice has, it's our unit of provisioning.
Yep.
And each job lands on one slice, right? And the slice has like, strong connectivity between the nodes.
Right.
And it's just basically sufficient to put those slices in one rack, for example, or not rack, actually. It's going to be bigger than a rack, in one zone. That's the best you can do, basically.
But I mean, I guess like on the job set, you're just specifying the appropriate device configuration right on the container side, and that's it, right? Yeah. So you don't do anything else on the controller side, right? It's like everything is
pretty much. Yeah.
Yeah, I
I
see.
mean, like you would need, like when passing like some environment variables to for each, pod to know who's who, and then one of them is going to be the driver, and it's going to set up everything, etc.
Yep.
But yeah, I mean, and this is like open, like it's where most of the jobs running is like MC JAX. It's multi-controller JAX, basically. It's quite similar to distributed PyTorch, I believe.
Yeah, that's correct. Yeah, and I guess like, so we still don't know like in terms of timelines for all this, features like stateful jobs, for example. We don't know like in terms of Kubernetes availability how we need to work with the Kubernetes community to deliver some of this feature right directly to the jobs. I think we discussed with you before about it, but some features might take time, right?
PVC per pod, you mean?
Yeah. For example, this one, or what it was like auto-scaling replicated job, I think it was.
That's not related. That's us. So we can do it on the job set side. But stateful, like, and the other one that you mentioned, which is creating one per job, that we can do as well. That's easy. But if you want to do a PVC per pod, that's a completely different. Like basically, you want to try to replicate what stateful set has, right?
I see. Yeah. I think it's different.
Not so you need that use case. I would be actually skeptical that you need it. Like, why would you need the PVC per pod?
Usually for distributed training, you just need one PVC for group of jobs, right?
So if you do that, then that's easy. That we can do in job set. Yeah, you're not blocked in anything.
Yeah, that's right.
But I guess that's my point. Like, instead of speculating, it's mostly about like really come up with the concrete use case that you have and focus on that. Because if we keep like, discussing hypothetical cases, there is this term like you ain't gonna need it, right? And you were just like, come up with those complex designs that will serve a very niche use case that I don't know if it will be relevant in like in the near future, right?
I think that makes sense. I guess like I can also like come up with the users like from IBM side who are using the PyTorch jobs right now in production. So maybe they can also help us to drive some of these like decisions as well, right?
Folks, we have 10 minutes left, so I want to leave space for the last topic.
Yeah, sure. Thank you for your time.
Thank you. Actually, we incremented the meeting from 45 minutes to 1 hour now, so
Oh, nice.
that's the response to multiple topics. Yeah, Amy, do you need to share your screen at all?
No, I'm good. I'm just trying to gauge context before I like bring up a GitHub issue. So I'm wondering if there's discussion around the visibility API at a cohort level. Like, understandably, that would be kind of difficult. But I think we potentially might have a need there. So currently, like, we want to have a transitionary state where we have something like this. Like, we have a cluster queue that holds all of our nominal quota within the cohort. There's one cluster queue per namespace, and then each of like the other cluster queues within that cohort or like teams or like projects, they have no nominal quota and they just depend on cohort borrowing. And so that's just a transitionary state. Alternatively, right, like to use the existing like cluster queue visibility API, what we don't want to do is this, where we have just like we have one cluster queue to many namespaces, because that would cause limitations, I'm assuming, with like cluster queue scaling. And also we want to have the previous transitionary state so that we can move into giving teams nominal quota or like guaranteed quota in the future. But due to like various compatibility reasons, like our initial iteration is that we just want to offer them no nominal quota per team. It's like, it has to do with vending and what our internal product kind of like the limitations of the internal product we're trying to integrate with. And so I'm wondering, is there interest or like technical concerns around introducing a visibility API at the cohort level? And then from there, I can, start a GitHub issue and maybe like a technical proposal. But let me link the Slack link that describes the topology that I'm just verbally sharing, in case you're interested in like not able to process verbally, because sometimes I can't. So yeah, just Slack the Kubernetes Slack channel. So yeah, I'll pause there.
First of all, I would encourage people to open issues as opposed to using Slack, because it's very easy to get things lost in the Slack. And even if we reject a proposal, which I mean we would do only after deliberation, right? Even if we do that, like there is a documented issue, so that if anybody in the future runs into a similar situation, they know why it was rejected, or they know what needs to change for the feature to be accepted. So for that, I will just open the issue. Did I hear something?
Oh no, I just said just an ACK noted.
But to the topic, to the technical aspects, I guess right now, so right now the algorithm is very much FIFO between different cluster queues, and I suspect you're okay with that. But we also have fair sharing releasing in a couple of weeks, which fair sharing brings the order more. It makes the order more unpredictable, because I suspect what you want from the visibility API is to know the order, right?
From the borrowing pool, yeah.
Like when is a job going to run approximately. So I guess, yeah, that will become much harder in the context of fair sharing to give an order in the cohort. I want to think about it. Right now I cannot think how how we could estimate an order, because it depends a lot on what's running and what's the share of each. Yeah, is fair sharing something you're interested in? I suppose you are.
Yeah, I think we for sure are. But yeah, I still think at like the cohort level, just like understanding, yeah, like I guess some estimation of time from the borrowing pool. I guess, yeah, let me go ahead and order like not order, submit a GitHub issue, and then kind of walk through how that could work with the fair sharing scenario.
Right. So I guess in the context of cohort, it might be easier to calculate an estimated time based on history rather than what's my position in the queue. I think position in the queue becomes a very abstract concept. There is no position
Okay.
in fair sharing.
And then also like maybe in the case where I think for this particular internal product, we may just use first in, first out. And then for like other organizations use fair sharing. So like maybe we can limit the scope for cohort sharing to just if you are using the first in, first out algorithm. And then I guess figure out like another way other than ordering to present it within the fair sharing context.
Yeah. And one challenge of estimating time is, well, having a record of what happened in the past, because queue is for the most part stateless, right? So it just knows what's happening right now. It doesn't record the past. So we will need to first introduce some form of storage. Or we could, in the past, we have discussed the idea of using metrics, just storing in Prometheus or something to get an estimate. But overall, like the topic has remained unexplored.
Okay.
If that's something you would like to contribute in, certainly we will be happy to listen to ideas.
Yeah.
And now we, as I was saying, we're closing this 0.7 release soon. So this would target 0.8. But I think I'm considering having a little bit more of a cadence on releases. So right now we've been trying to target 2 months, but in practice we're doing every 3 months, and some features are getting delayed, or some features that are ready already are getting delayed because of other features that we're waiting for. So I am trying to just kind of like be more strict about the time and just cut a release every month. Whatever is in goes in, and whatever is not, well, has to wait. Kind of like Kubernetes is. So with that, I'm hoping to have a better cadence, so you don't have to wait that long for new features. But it's not an easy task.
Yeah, it sounds hard. Cool. Yeah, thank you for your thoughts. I'll definitely think about the fair sharing component, but this is useful. So yeah, let me submit a GitHub issue and then discuss further on that thread.
Yeah, and if I remember correctly, you're also interested in hierarchical cohorts.
Yes,
which
for
will
sure.
add another dimension.
We'll make it, yeah, more tricky. Yeah.
Actually, well, I think that actually kind of, if we solve the one level cohort, I think it kind of extrapolates to multiple level, but that's just a speculation at this point.
Flux handles hierarchies really well. I'll just throw that in there. Sorry. Actually, I was going to say, Amy, when you open the issue, would you post a link to it in the working group Slack?
Yeah, for sure. So yeah, this is just an initial thought. I haven't thought
No, I
through all
won't.
of,
I
like, the
won't.
technical
No, I don't
things.
think
Yeah,
we won't like judge or anything. I'm just interested
yeah,
in the topic.
yeah. Happy to. Cool. Thank you. That's it for me.
We're at time. Thank you everybody for coming. If you have topics, don't forget to propose something. We already have kind of a full agenda for the next PST friendly meeting, but the agenda for EU friendly meeting is empty right now. Well, thanks for coming. See you all.
Cool. Thanks, everyone. Bye.